Hi everyone, we're going to have more practice solving rational equations. This is part 3. I think actually part 3 is actually easier than the part 1 and 2s that we did. But nevertheless, here's some problems that are different than the ones we did. Except for this one. This one looks very similar. So we'll go ahead and get started, and we're going to do the same steps we did before. The first thing we want to do is find what makes the denominator 0. In this case, nothing. There's no x in the denominator, so any solutions are fine. Our LCD, our least common denominator, is 6. So what we're going to do is multiply. We're going to clear the fractions, or make it fraction free, by multiplying everything by 6. So this will cancel here, and you're just left with 2a minus 3 equals 3 goes into 6 2 times. 2 times 2 is 4, so you get 4a. 2 goes into 6 3 times, so 3 times 1 is 3. And I'm going to go ahead and subtract 3 from both sides. Let me do it this way. Minus 3 from both sides. And I'm going to I'm going to subtract 2a from both sides. Okay? That cancels, you get negative 6 equals 2a. So a is negative 6 over 2, which is negative 3. And we had no restrictions, so we're good to go. Next one. Same thing, we have no restrictions because there's no variable in the denominator. There's no x. So our common denominator, or our least common denominator, is 14. So I multiply each piece by 14. 14, 14, and 14. 7 goes into 14 2 times, so it's 2 times our numerator, minus 2 goes into 14 7, so that's 7 times 6. I'm just going to write 42. Oh, that's a b. Is that a b or a 6? That's a b. So it's really going to be, sorry about that. That's going to be 7b. 14's cancel here, so we're just left with b plus 3. Now I'm going to simplify. You get 4b minus 6 minus 7b equals b plus 3. I'm going to simplify the left side. I'm going to get negative 3b minus 6 equals b plus 3. I'm going to move my b's onto the right side, so I'm going to add 3b here. Therefore, I'm going to subtract 3 from here. This cancels. Here I get 4b. This cancels, and I get negative 9. So b is negative 9 over 4. You divide both sides by 4. And that's your answer there. The next one, this time we do have an x. In this case, we have our restrictions that x cannot be 0. Alright, so we can't get 0 for our solution. My common denominator, my least common denominator, is 10x. So what you did is you took the 5 and the 2, the common denominator of that is 10. The common denominator of x is just x. You pick the biggest power, and our biggest power is 1. So I'm going to multiply each piece by 10x, my LCD. This goes, 5x goes into 10x 2 times. 2 times 3 is 6. 2x goes into 10x 5 times. 5 times 7 is 35. And if I write this in fraction form, 1 goes into 10x times, so we're left with 1 times 10x is 10x. So we get 41 equals 10x. So x equals 41 over 10. And it doesn't bother our restrictions on the domain, so we're good to go. Okay, here's one with k. So my restrictions are k cannot be -2, because if you have -2 here, you get 0 here. And k can also not be 0. You plug 0 into this one, you get 0. And that's 2 over 0, and that's impossible. So our LCD, you have to take each piece. This is a unit, this is a unit. So our LCD is k times k plus 2. You need both pieces. And just think, if you didn't have it, you couldn't divide through. So I'm going to multiply each piece by k times k plus 2. K times k plus 2. And I want to put this one on this side. K times k plus 2. Alright, this one doesn't look too good here. Anyway, what happens? These two cancel, so we're left with k. K times 5k, multiply, you get 5k squared. Here, the k's cancel, so you get plus 2 times k plus 2. Here, nothing cancels, so you just get 5k times k plus 2. Alright, now simplify everything, and we're going to get 5k squared plus 2k plus 4 equals 5k squared plus 10k. Now what happens when you subtract the 5k's from both sides? They disappear, the 5k squareds, and then we're left with this part. So I'm going to subtract the 2k from both sides. So I get 4 equals 8k, so k is 1/2. And it doesn't bother our restrictions, so our solution is good. And our last one, we have our restrictions are m cannot be -1 and m cannot be 1. Because you plug those in, you'll get 0 in the denominator. And we have to take this whole piece. My LCD is both of these together. These are both separate units. They're both different. So you get m plus 1 times m minus 1. Now what I'm going to do here is, instead of each piece, I'm just going to distribute. My LCD is m plus 1 times m minus 1. Now on this one, the m plus 1 cancels, so I get m times m minus 1. This case, my m minus 1 cancels, so I get 5 times m plus 1. Kind of like crossing here, right? And then nothing cancels here when you distribute there, so you just get, I'm kind of squeezing this in, m plus 1 times m minus 1. Now I'm going to simplify, so I get m squared minus m plus 5m plus 5 equals m squared minus 1. You FOIL that out. That's your difference of squares. Now, what's going to happen here, like last time, the m squares cancel. This equals 4m plus 5 equals -1. I'm going to subtract 5 from both sides. So I get 4m equals -6. So m equals -6 over 4, which equals -3/2. So our solution set is -3/2, which is fine because it is not in our restrictions. Okay, the next problem set we're going to do is very similar to these. It's going to be called Part 4. So if you get this part and the Part 2 and 1, I think you're good to go. Thanks and have a nice day. Bye-bye.